Hi, I'm Harry Halpin, the CEO of Nym, and I'm here to present our paper on Nym Credentials. So we're a new Swiss company up in Neuchâtel. And with no further ado, let's go. So Nym is a company which is essentially based around building infrastructure for privacy, taking privacy enhancing technologies, work from the academic literature, and bringing it to essentially the user section. So in this paper, on a large extent, what we're doing is we're taking research from anonymous credentials, solving some of its problems using blockchain technology, and using it to tackle one of the largest problems in the world, which is digital identity. So how it works is that Nym Credentials, which privacy preserving decentralized identity blockchains, essentially go after one of the perhaps less considered but most important applications in the world, which is digital identity. There's been a lot of standards for digital identity, including OAuth, decentralized identifiers, and so on and so forth. We're going to review those, and we're going to discuss our own new credential system, including all the new actors and the information flow, and evaluate it using real world code before looking to next steps. So Facebook Connect is perhaps not as famous as Libra, but needs to be, because Facebook Connect is the identity system for most of the world. There are possibly more Facebook Connect transactions than even Visa transactions, and that's currently. And the reason is whenever you use an app, if you want to have single sign-on, you don't want to remember multiple passwords, which most of the world does it, you simply click a sign in with Facebook button, and if your Facebook account is open, then a transaction happens where Facebook logs you into the new service and possibly shares data with that service, or vice versa. And this also happens with sign in with Google, Twitter, and other applications. And this is sounds incredibly convenient, but it comes at a huge cost. Namely, Facebook knows where you've been, which app you've been using, and when you've been using it for every single access to that application provider. And that can be pretty dangerous. You might not want to let Facebook know, for example, that you're using, I don't know, Tinder, you're using a Bitcoin wallet. There's all sorts of things that you might want to hide from Facebook. And Facebook is using a well-known IETF, Internet Engineering Task Force standard for this technology called OAuth, which mysteriously stands for Web Authorization. OAuth essentially is a way to share data, and was invented all the way back in 2006 and standardized later. And it divides the world into some sort of different actor roles, and we're going to use the OAuth is quite complex. We're going to use the simpler terminology from OpenID, which they inherited from an earlier standard called SAML, security assertion markup language. But essentially, the world is divided into users. These users are people like you and me. They have attributes: name, age, date of birth, place of birth, photos, contact list, all sorts of things. There's identity providers that manage user attributes. So these identity providers, in the case of Facebook Connect, is Facebook itself. They control all of your photos. They have some personal information of yours, your date of birth, your phone number, and other apps we call service providers, and they want those user attributes. So this could be anything from using Facebook to sign into Twitter, or Facebook to sign into LinkedIn, or Facebook to sign into, well, about anything. Now, OAuth was invented for a good reason. It was invented, standardized the IETF, essentially because before OAuth, large websites were just sharing your Gmail password or sharing your Microsoft password between each other. That was viewed as unsafe, which it was. At the same point, now that's been standardized, Facebook Connect, sign with Google, et cetera, it's essentially the centralized identity provider for most of humanity. And how it works technically is very simple. You simply have some sort of shared secret between the user and the service provider. That shared secret is sometimes hash and salted, and it serves the capability. It proves that I have access and want to give access to someone else. So for example, I get a capability from a service provider. I then want to grant that service provider access to my personal data. So I basically give that token to the identity provider. The identity provider says, oh, thanks for granting me access to that service provider. Then the identity provider talks to the service provider and can basically send them all of your data. It provides a right of access. Now, there's a lot of attacks that come along with this. Obviously, identity providers can impersonate a user. This is the mixed up IDP attack noticed by FET and others in 2016. In general, the security of OAuth is reducible to TLS 1.2, and earlier versions didn't even use TLS. People who just steal these tokens by sniffing Wi-Fi and impersonate people on Facebook. So this was viewed as Mozilla fire sheep, if I remember correctly. This was viewed as very dangerous. So obviously having a giant centralized honeypot of identity data is not a good thing for humanity. So this new standard by the World Wide Web Consortium over a web browser, competing standards by the IETF, was cooked up by Drummond Reed and a bunch of other people from a company called Nym, which is obviously whose goal and motivation is the reverse of ours at Nym, because we don't want everyone to have a Nym forever, but we would like short-term pseudonyms and to be anonymous. Okay, now that back from that minor side point, Drummond and friends built this new standard, and it does something which is actually quite attractive. It takes out, at least at first glance, the centralized identity provider, Facebook, and replaces it with a blockchain. And not only is it replaced with a blockchain, but you can use all of the notions from blockchain-based key management, such as the key-based identity for a user, keys being put on the blockchain, in order to manage identity. The big trick that DID does is that service providers essentially resolve keys to what's called DID documents with some form of attributes. And these keys and these DID documents can be stored off-chain. They can be stored in permissioned blockchains like the sovereign blockchain. Now, this all sounds good, but there's a real big danger. And the danger is pretty simple. All of the keys are stored on a public chain or a permission chain. And that every time the service provider wants to access these keys, that service access, particularly on permission public chain, is public. And so the correlation between the times of when you log in, what you log in with, it's not as obvious to Facebook with this one centralized party, but there is a bunch of material on chain and timing attacks that can be done by watching that chain that, for example, even the DID specification notices that these correlation attacks are quite plausible unless pretty extreme measures are used. And that's a topic for perhaps another paper, but regardless, it's if there's one thing worse than giving Facebook control of your whole identity and letting them know whenever you log in and access an app, it's possibly letting the entire world know when you log in and access an app. This is perhaps even worse than Facebook identity from a privacy perspective. Now, luckily there's a whole field of literature from this wonderful paper called Security with Identification to make transactions that can make Big Brother obsolete by David Chom way back in 1985. And this presents an alternative way to solve the identity problem with privacy. And it essentially builds off the Dave Chom's earlier well-known work on blinded signatures for cash or DigiCash. But instead of cash, you're signing essentially user attributes. So it's the same game. You have an issuing authority. It signs credentials on behalf of their users, can assure their validity. But the users, because they're blindly signed, the users can basically give blinded attributes to the issuing authority. The issuing authority can return those blinded attributes. Those blinded attributes can then be deblinded and sent to various service providers that need them. This does provide privacy, but at a cost. Effectively, it's centralized. Now, it has been implemented in various, I would say, better versions. There's been wonderful work by Stefan Brands. Uprove and Microsoft almost got this whole thing into Windows. European Commission work around Prime, Prime Life, ABC for Trust, which led to IDE mix, which is probably the most advanced of these systems by the legendary cryptographer Jan Kamenisch, now at Dfinity. Nonprofits still manage these systems like IRMA. However, these systems never really took off. So there has been some attempts to basically revisit this problem using other privacy-preserving cryptographic techniques, which may be more compatible with OAuth, which is Unlimited ID by myself, George, and Marios a few years ago. We tried to use algebraic max to preserve privacy, and work by Garmin and Ian Myers, other folks, on using blockchains and RSA accumulators. So it's all very nice, although not particularly scalable. So what we want to do is we want all the advantages of anonymous authentication credentials, but we want them to be decentralized. So luckily, there's been this wonderful new paper called Coconut Credentials, developed by Alberto Sannino, George Denisis, our ex-co-founder, now at Libra, and others. And this technology is really interesting because it provides unlinkability. Identity providers cannot easily link the credentials. Selective disclosure, the users can determine what attributes to show, and they don't have to show just public attributes. They can like a name or address or whatever that you don't mind being public about. But they can also have zero knowledge proofs of private attributes, which is very useful, for example, for possession of key material and other things that you don't want to show directly to a service provider. You can use this kind of proof of key material to establish persistent accounts. And of course, the main breakthrough is that this entire Coconut system is decentralized. It has, it's resistant to Byzantine faults, uses a very standard consensus system. And the reason it gets away with this is that the credentials, the big breakthrough is that they're aggregate threshold anonymous credentials. So you only need the issuing authorities up to the number of the sort of the majority, the quorum, in order to basically get Byzantine fault tolerance. And that really helps on availability. However, there's a big problem with Coconut, and this problem is pretty simple. This problem is that if you want to use, let's say, lots of attributes, each of these attributes, there's Coconut credentials are constant length, so they're all sort of encoded in the last elliptic curve point by using multiple keys. This means that validators have to have different keys for every attribute. This means you cannot easily add dynamic attributes. This is fine for a system like perhaps, Facebook, Libra doing KYC AML, using, very standardized Swiss attributes where all the validators know all the attributes ahead of time. But if you could imagine an open-ended system, you would want to have lots of different attributes and lots of different people sharing different kinds of attributes, and new service providers coming up and down, adding new attributes, subtracting new attributes. So we really need it to be extensible. New attributes have to be added by service provider dynamically. Also, why not add in some sort of Sybil resistance? Why not rate limit the amount of usage of anonymous credentials? You can connect anonymous credentials to payments, and this can all be done through tokenization, as we'll see shortly. You want to have the classical identity provider tricks, which are currently that flow from open OAuth. It's not really part of Coconut. And you can imagine some other more advanced features like persistent accounts based on derived keys, et cetera, et cetera. So Nym Credentials provides all of this. It doesn't do it for free, it takes a bit of a cost. How it does it is it adds new components to the classic anonymous authentication credential flow. It adds, in particular, blockchain, sometimes even two, and validators. But you can see that this allows us to mediate new kinds of anonymous transactions where essentially the user can provide credentials to their service provider can check the credentials if it's valid or not, but the linkability between the service provider and the user and the service provider and the validator is all broken. But you can see over on the linkability side, the classical kind of OAuth flows identity providers are still kept, which is quite useful. So let's walk through this one by one. In step one, the users, we're going to assume they can somehow access what we call Nym tokens. And they want to access a service privately, and they're happy to, a Nym token is a voucher that kind of is the proof of right to access for a certain amount of time for a service. For example, the token could mean, I would like to have private VPN access for a week. I don't want to hand you my private payment details. I just want to show you a credential, and that shows, that gives you proof that I can access the VPN. Or I might want to have the ability to send messages for a month using a more advanced version of Signal without a phone number, all sorts of things. Essentially, the token is a voucher for the usage of the service provider. However, tokens, if we're going to use a classical Bitcoin style token or ERC20 compatible Ethereum token, these tokens are not anonymous, they're public, and they're public by default. So we have to do something to make them private. In order to do this, what we do is we establish a smart contract, which we call the Nym smart contract, on what's called an external blockchain. This external blockchain may be Bitcoin, it may be Ethereum, we don't know, we don't care, it could be some new chain. However, all that matters is that the user can obtain Nym tokens and send them to a smart contract. It doesn't even have to be a smart contract. It can even be for Bitcoin, like a address, counterparty style, which other system components of the Nym system, the validators, just watch that address. So what happens, the user somehow obtains these Nym tokens and then sends them to a what's called a Nym smart contract. And this sort of gets the process going. Once that's been done, the user may also want to have some attributes. For example, they may have all the proof of origin of funds that you need for Swiss KYC AML, or they need, in which, there's quite a lot. There's passports, identity data, a source of funds, all this stuff. Regardless, they take all these attributes, and they may need to give them the identity providers. For example, passports may need to be verified by governments. Proof of origin of funds may be verified by banks. These are all different identity providers, but the key point is that the user can just walk through as many identity providers as they want, get digital signatures on all of their attributes, and just collect all of these. This step's optional because some users, for example, for the privacy enhanced VPN case, they may not want to attach any attributes to their usage of a VPN or something like Tor. They just want to have a credential that shows that they have, as Snowden put it in the Web3 Summit, the right to be there, the right to use the service. So again, let's think through. What you need in this kind of credential, so you have these public tokens, you need a sort of private anonymous credential. What's the minimum set of things you need to enable things like pseudonymous accounts, persistent accounts, and these sort of things? Well, you need a secret. So this is a private secret, that never leaves the client device, or does so only in a secure and private manner. And this proof of possession is used for account ownership, for any long-term account information, but most importantly, use to link multi-attribute credentials. So essentially how Nym improves upon Coconut is we imagine you have a new little kind of a single-use Coconut credential. You link them all together using proof of key possession. Secret possession, to be more precise. Now, also, credentials may be attached to tokens. This is, again, new for Coconut. You don't want to split the usage of tokens into denominations like a classical Chime and eCash. You break the denominator set. What you want is you want to just prevent double spending, not just for tokens, but for anything that you might only want to use once. So you have a serial number. This is sort of private nonce, which we use later by putting on a blockchain in a blinded fashion to prevent double spending. You also have the attribute itself, which could be public or private. Private using the non-interactive zero knowledge proof of your choice. Commitments is what we typically use. And you also have a validity epoch. The validity epoch is the time period the credential gives you to access the service. So you imagine that the set we generally have in mind is that all these services pay by month. So every month I want to pay Proton Mail, I want to pay Proton VPN, I want to pay whatever privacy enhanced service I have, Najala. And this says, I want to have the VPN access or email access for 1 month. So before I pay, I get that credential, I display that credential to Proton Mail. And then at the end of the validity epoch, the Proton Mail basically takes the funds and puts them into their own account. They can prove how many users they've had for that epoch. So the epochs are important, and you can refresh credentials, which is very important. So your credentials do not have to be used the epoch. This allows us to stretch out the anonymity set over multiple epochs. So let's walk through the next step. So how do I get one of these credentials? Well, I take all of these attributes, which I gathered in the previous step with all these identity provider signatures, if necessary. I collect them, I commit to them, I put them in this sort of credential format I just explained to you, and I send them up to the validator, which could be a standard, standard issuing authority, also maintains a blockchain, for example, a Tendermint blockchain or whatever. Regardless, it signs these attributes and sends them back. And what they send back is not a full Nym credential, but what's called a partial credential. That's how you get the threshold signature. So the validators, basically, all they do is when they get this bunch of commitments, which are Elgamal encrypted, because you might want to randomize them. And then the validators check to see if the amount of tokens you transmitted into the smart contract indeed matches the amount you want. Puts you have to have the minimum amount. You can also have free services that have no tokens, but just take that part out if you don't want. But regardless, if you do want to have sort of paid services or services where they can count the number of users they've had for capacity reasons, you basically take that token and you transform it into credentials. That's another attribute in the credential. It's checked by the validator, so you can't cheat. The validator, once it obtains consensus, returns whatever the 3 of 5, etc. consensus is. I think it's 2/3 plus 1 for Tendermint. And you keep repeating this process, and the user collects all of these attributes and then basically merges them together, getting the aggregate threshold signature, which essentially lets them create what we call the full Nym credential. Then in the next step, the user essentially re-randomizes this credential, because you want to make it unlinkable, and then uses it to show these attributes to a service provider. This is the step of selective disclosure. And the essential technique here is that the user essentially takes the credentials, determines what, if any, that wants to reveal, shows in the service provider. As soon as the service provider gets the credential, if it does include tokens or some other one-time use attribute, it wants to check for double spending. So it writes a blinded proof of that serial number. So the serial number is S, like a GDS, to the chain in order to prevent double spending attacks. So it's, as soon as it gets the credential, it writes it to the chain, because otherwise someone else could write the chain and claim that of that token or that user, and the user can then spend it multiple times. Now, what's important is that then at the end of the epoch, each service providers collects their credentials. They've, let's say, had, I'm a VPN provider, I've had 50 users this month, or 50,000, let's say, and then I display them to the validators. The validators say, oh, excellent, you've had 50,000 users, maybe they reward you. For example, if the users paid, let's say 2 tokens a month, they give you 100,000 tokens back, and they just check the double spending before handing you all the tokens, because they would have access to the blockchain where you've written this kind of blinded serial number. So this gives you a whole kind of virtuous cycle. I think that's, so the value is flowing from the user to the service provider. It's mediated by the validators. And that plus anonymous credentials is what buys you the anonymity of the Nym credential system. And you can use this in all sorts of neat ways. This is another way of looking at it. So we're just going to review. You have, let's say, an ERC20 blockchain. The user sends them tokens, then they do a bit of fun collecting these attributes, making these partial credentials, these attributes together, linking all these coconut credentials into single Nym credentials, and they do this by talking to the validator, sending up those Elgamal commitments, getting them back, checking, the validator checks the tokens by talking to the blockchain. Now that's all completely public, but then the next step, there's a credential. The credential essentially is shipped to the service provider after being randomized. That, boom, makes it anonymized. And this is step 3. And then, we split these steps out in this diagram. The service provider then checks to make, as soon as it gets a credential, writes into the blockchain. And then the last step, the the validators which run the smart contract, which got the user tokens in the beginning of the month, or the beginning of whatever the validity epoch is, and then check at the end of the epoch, for example, the end of the month, and say, I checked your proofs on the Nym blockchain. It's true. You did get this many users this month. Let's send you their tokens. And then if you use techniques like if you added, for example, split and merge to Coconut, then you could essentially, you could put more tokens in the smart contract than you use per month. You could put less tokens in multiple times, eventually get to that point. And then you could basically take tokens, use them, get change from the credential itself. And this would make everything unlinkable. So we're going to do future formal work to basically add these split and merge operations to the credential system based on Coconut, which still doesn't have all its formal proofs, but Jan Commonish has done some stuff more or less in the right direction that we believe we can adapt. Now, we did code all of this work up. It's pretty fantastic. It's in Go. We are now recoding in Rust thanks to a grant from the European Commission and hopefully others. But what we can show from these graphs is that everything is pretty performant, goes on in less than a second. But what you can see is that certain things are constant time, like re-randomization or verification. You're just checking signatures and randomizing credentials, just multiplying by a blinding factor. This is all great. What you notice with the unblinding and aggregating or blindly signing with both public and private credentials or showing is that, of course, with showing and blind signing, the number of operations increases as your number of attributes increase, because you keep seeing these one attribute Coconut credentials all around to different that just takes more time. You have to keep repeating the same cryptographic show or the same sign on different little micro Coconut credentials that you didn't have in a single Nym credential. On the other hand, what's very interesting is the fact that the unblinding aggregating requires getting partial credentials and gets slower the more validators you have. And that sounds crazy, but it makes a lot of sense. The more validators you have, I need to get 2/3 consensus plus 1 over 100 validators. I have to all of a sudden talk to, oh geez, I have to talk to 66, 67 validators rather than just talking to 3 when I have 7 validators. So there's a certain now network communication there, which adds latency. You can see in conclusion, so we have a lot of more testing we have to do in order to basically determine how the Coconut credentials work in terms of what is a fundamental trade-off, which was maybe not clear. What Coconut and Nym credentials do is we trade off the availability of the validators, the availability of the issuing authorities versus the trusted setup, the common reference string of ZK snarks, and we believe that may give us some advantage in certain aspects of improve and verify time. Although ZK snarks move very fast, so it's hard to tell. Regardless, also the network latencies are going lower and lower, so we're also going to become faster over time. But regardless of how we compare to ZK snarks, when you look at non-ZK snark techniques, it's pretty clear and this is all more detail in the paper, achieve all the properties that we were set out to achieve, going above and beyond other private identity schemes. Now, there's a lot of next steps. We need formal proofs. We need to add these split and merge functions to Coconut. Validators currently in Coconut and in Nym it's not discussed how they update. Obviously, when you refresh, the reason we have epochs in the system is we do want to allow things to refresh. And between epochs, a validator might go down. Maybe he's kicked out the set. We want to have the ability to add new validators and subtract ones over time. This may require incentives. We're currently looking at a lot of different techniques, Agalos and or Boris's stuff to all sorts of kind of nifty new proof of work schemes. Regardless, we need to ensure the availability of validators and update the validators over time. So essentially what that would mean is that when you get a credential, of course, it's signed by 2/3 of validators. This validator set changes. You get it re-signed by using a refresh at the end of every epoch. The big advantage in Nym Credentials is extensible, but we need to have sort of tools to make people allow people to add services, add these attributes, and of course, make everything much faster by recoding it in Rust. A long-term goal in Nym, which is not really discussed in the paper, but there's new papers coming, and more importantly, this code already works, is we're trying to use these credentials to help incentivize a mixnet or anonymous communication channel, which is going to prevent timing attacks between user agents and service providers. And even Zcash currently doesn't even have very simple stuff like Tor. We're aiming for a mixnet which provides resistance to even massive passive global adversaries like the NSA, for example. A lot of different use cases. I talk a lot about decentralized VPNs. They don't really need much personal data, just some proof of payment or proof of right to access. But you can imagine things like Signal would need tons. Signal currently uses centralized algebraic max for group messaging, but you can see they could expand a general purpose anonymous authentication system. And of course, the identity management use cases mentioned earlier, such as KYC/ML. There's even rumor that Libra is using a modified version of Coconut for their privacy enhanced KYC/ML. After all, it's the same scientists from like George that built Coconut are now working over at Facebook. We do have some supporters already. Status is working with us, building on the mixnet, but we hope to eventually get them interested in credentials. The European Commission has just announced funding of the credential effort, and there's more people and more blockchains interested. We have a growing team, including my favorite new hire, Alexi Russo from Bitty, and Dave ex Facebook, and lots of Jared, Andrew, who's built lots of this Nym Credential stuff, and maybe even you if you're interested, so just reach out. And the reason why we're doing this is because we believe that identity is the linchpin of modern surveillance. We need a way to have the advantages, the power of identity without surveillance, without any kind of centralized control. And that means that privacy is not secrecy, but as put by Eric Hughes in 1993 in the original Cypherpunk Manifesto, privacy is the power to selectively reveal oneself to the world. And this is a very hard problem. We do believe Nym Credentials is the next step in making this vision a reality. And one day we will achieve it on a mass scale in order to preserve a free society. So thanks a lot. I'd be happy to answer any questions, or how should we say, YouTube comments. And I hope to see you all live in Lucerne or somewhere else in Switzerland sooner rather than later. Thanks a lot. And let me turn this off.